Hey guys, today we're going to take a look at analyzing some quadratic functions. Now you'll notice the sheet has already been started. That's because I've had quite a few difficulties getting this one to work, but that's okay. We've got it now and everything should be fine. So anyway, we're going to look at some linear equations and quadratic equations. Remember, linear equations are equations that produce lines, and they often have the form y equals mx plus b. Whereas quadratics are equations that produce parabolas, which will often have the form ax squared plus bx plus c, which was standard form, or ax minus h, quantity squared, plus k, which we called vertex form. So both of these relations are also functions. So first of all, we're going to take a look at some first differences. So I've already filled out the first part of your table of values here. So we just plug in the different versions of x that it says, and we come up with these answers here. And what we're going to do is we're just going to subtract. Okay? So we're going to have -2 minus -5. Okay? And that's going to give us 3. And then we'll have 1 minus -2, which also gives us 3. And then we'll have 4 minus 1, which also gives us 3, and 7 minus 4, which also gives us 3. So what is true about the first difference is that they are all the same. So we'll write the same. And thus, if we have a linear function, the first differences are equal. Okay, in this case, equal to 3. They're all the same. Okay? If we do a quadratic, okay, and again, we'll just start with doing our table of values here. So we sub in our -2 times 2 times -2 plus 1. And that is going to give us 17. If you don't believe me, you're welcome to try it out on your own. But then we're going to go through the rest of them. And I'm just kind of cheat a little bit because I have already done these. So I'm going to say that one's 6, this one's 1, this one's a 2, and this one is a 9. So now what we're going to do is we're going to do our first differences. So we're going to say, what's 6 minus 17? Okay, so 6 minus 17 is going to give us -11. And then we'll look over the next one. We'll say, what's 1 minus 6? Okay, and we don't have to show our work for all of them, but that one's going to give us -5. Then we'll have 2 minus 1. I guess I am going to show my work for all of them. I already skipped some, or cheated earlier, so I guess it's okay. So that's going to give us 1. And then finally, we'll have 9 minus 2, which is going to give us 7. So right off the bat, you can tell this is not a linear function. We already knew that because we know that equation is quadratic. But so the first differences are all different, so we know it is not linear. And what we're going to do now is we're going to do our second differences. So we say -5 minus -11. Okay, and that's going to give us +6. And then we'll have 1 minus -5, which is also going to give us 6. And then we'll have 7 minus 1, which also gives us 6. So they are all the same. So what is true about the second differences? They're all the same again. And thus, for quadratic functions, the second differences are equal. The second differences, I should say, are equal. Okay, and there we go. Okay, so whether you remembered that from last year or not, doesn't matter. Whoops. Doesn't matter. Now I can't skip over pages. Oh my goodness. Oh, it's not gonna let me. Oh geez Louise. Well, hold on. Maybe I better pause this and figure it out. Well, I'm not sure how I got over to the second page, but I did finally get over to the second page. So here we go. So far, we know how to distinguish between linear and quadratic functions by following first and second differences. So what about their equations? So we're going to look at some sample equations here. And you're going to notice that I've put some exponents of 1 for the linear equation. So I have x to the power of 1. Normally we wouldn't write that 1. But remember, if you don't have an exponent, if it's just an x or a y or whatever it is, there's an invisible exponent of 1 there. It's just that there's no real reason to write that. So we don't do that normally, okay? But for the purposes of this, we're going to look at this, or we are going to write it, because it makes it really obvious. If we look here, the highest exponent we have is that 1. And this one has an exponent of 1. And so does this one. And so does this one. And that's what makes these linear, okay, is that the highest exponent is 1. So we'll say the exponent, well, that's an E. Exponent doesn't look like, oh my goodness. Exponent is 1, okay? So what do quadratic functions have in common? Well, they have an exponent of 2. Exponent of 2. There we go. All right, because you can see there's our 2, there's our 2, there's our 2, there's our 2, and that's what makes them quadratic, okay? So the word degree is used to describe the type of equation you have. The degree of a polynomial with a single variable is the value of the highest exponent in the equation. So if we look through here, so what we do is we just want to know, is the degree 1 or is the degree 2? If the degree is 1, it's linear, and if the degree is 2, it's quadratic. And it's usually pretty easy for something that's linear, because if we look here, there is only one variable, and it has an invisible exponent of 1. So the degree is 1, which means it's linear. Okay, what you have to be careful of is for this second one, which is a quadratic here, we've got an exponent with, or we've got a variable with an exponent of 2, and then we've got an exponent with an invisible 1. Or sorry, a variable with an invisible exponent of 1. And all that matters is which one's bigger. So the fact that this one is here, the 1 is here, is kind of irrelevant. We don't care about that. All we care about is this 2 right here, because the 2 is bigger. Okay, so that's what gives it the degree of 2, and that's what makes it quadratic. So for the next one, you can see the only exponent is the invisible 1. So that makes this a degree of 1, which makes it linear. Okay? But if we move to the next one, we've got an exponent of 2, which makes this one quadratic. Okay? Now, this next one here, the degree is going to be 3, because even though I have an exponent of 2, I don't care about the 2. I care about the biggest one, and the biggest one here is a 3. So this has a degree of 3. Okay? And what type of function is that? Well, we haven't learned either. We haven't learned that. That's actually called a cubic. And you won't likely learn about that because it's really not all that important. Okay? Similarly, here we've got one. It's got a 3. It's got a 4. We don't care about the 3 because it's smaller. All we care about is that 4. So the degree is 4, which makes this one, it's actually quartic, but again, we're not going to learn about that. And so on a test, you could just write not linear or quadratic. Oh. I'm writing, but it's not showing up. There it is. Okay, so it's not linear or quadratic, or you could even just write other. I would accept the word other as an answer. Okay? There we go. So now we can use the degree of the function to determine what type it is. Isn't that great? And of course, the answer is yes. Yes, it is great. So one of the things, since we are dealing with functions, but not all equations represent functions, we're going to use a special type of notation when using functions. It's called function notation. So we already kind of talked about this a little bit on our first lesson. And that's where we have, instead of writing a y here, we're just going to write, f of x. Remember we said is how we said it. And of course, it is important to remember that that f and that bracket and that x are completely attached. We can't separate that. That's one thing. It's no different than if we had the y. It's just a different way of writing it. And so that's how you know it's a function. If it's written in function notation, it is a function. Okay, if it's not a function, it shouldn't be written that way. Okay, so, hey, I got it first try that time. So let's take a look here. I'm going to give you some tricky ones. Okay, so we're going to state the degree of these functions. Now, where this is difficult is that you can't just look at one like this. If you've got one where there's brackets like this, we're going to have to use that distributive property, or the rainbow rule if you called it that. Okay, and we're going to have to multiply it out. Once we multiplied it out, then we can just look and see what the degree is. So we say 3x times x is going to be 3x squared, and 3x times 1 is going to be 3x. So now that we've got it written out and there's no exponent, or sorry, there's no brackets, we're just going to look at the exponents. We've got a 2, we've got an invisible 1. We don't care about the invisible 1 again because we've got a 2. So the degree, what? I don't even know what's happening with this thing today. Degree, well, there we go. Degree is 2, okay, which means that this is quadratic. Okay, so let's take a look at this next one. And this one's not as obvious because you can look at it and see that we've got these squareds, and you might think, wow, it's got to be quadratic, and it might be, but it might not be. So let's take a look. So what we're going to do is we're going to write this out like x plus 2 times x plus 2. Okay, we still got our minus x squared there. And we're going to use FOIL on this. Hopefully we remember FOIL. That was where we said x times x times 2, 2 times x, and 2 times 4. Or 2 times 2, I just said the answer. So, oh, I'm back to blue. I'm on blue. There we go. So we get x times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. Now we've got our minus x squared. And now we get to collect our like terms. And if you look, we have an x squared and an x squared. And because one's positive, one's negative, they actually cancel each other out. And we have a 2x plus 2x. So we're left with 4x plus 4. And if we look there, there is no exponent. The only exponent is the invisible 1, which means that the degree is 1, which means this is linear. And there we go. Okay? All right. So we're going to do a brief little review here on the parabola. So I've got a parabola drawn here. Now the equation for this one is y equals 3 times x plus 5 squared minus 4. So the first thing we're going to do is we're going to find the vertex, because we haven't really talked about what the vertex is. Okay, we briefly talked about it. But remember, the vertex is just this point right here. It's the turning point. It's the minimum or the maximum. We talked a bit about this with the domain and the range. Okay, and so it's just going to be that point there. Okay, so in this case, it's just going to be -5 and -4. Okay. The next thing is the axis of symmetry. I've actually written the answers here for you, but anyway. So there's the axis of symmetry. It is x equals -5, and but you're thinking, how do you know that? And it's just that the axis of symmetry is just the line that cuts that parabola in half. It's this dotted line right here, and it's always going to go through the vertex. So whatever this number is right here in the vertex, that x value, is always going to be the number we're going to use in the axis of symmetry. Okay? So it's fairly, if you have the vertex, it's fairly easy to come up with the axis of symmetry because it is just that x value. Okay? This parabola, I'm not sure what it wants us to put in the parabola. I think I was supposed to put the equation there, but it gives me the equation already. So I guess we can just, we'll give it a check mark so we know, yes, it is a parabola. All right. And so that's it for today. I'm not 100%. Check on the website and I'll verify whether this is the correct classwork or not. Because I don't know if it is or not. Because remember, I messed up on the last one. So hopefully I didn't mess up on that one. But if I did, I'm going to write into the website what the homework is for, or the classwork is for tomorrow's lesson. Okay? So until next time, go Sabres.